All right. Hello, everyone. For the tomorrow's case, which is Marriott rooms forecasting, we were not able to discuss the concepts about demand forecasting in the class yesterday. So what I have done is I'm planning to record a short video on what are some of the tools and techniques that you would need to apply in that particular case. So this is going to be a very short video and what kind of tools or techniques are there. And I'm sure this will help you in addressing that particular case very well. All right. So while there are different types of forecasting that you can think of, one of the key things that we will focus in this particular session or in this particular course as well is demand forecasting. Now, why demand forecasting? The importance of demand is has been continuously required for us in terms of whether you look at your process design or whether you're talking about inventory. Demand is something that is very, very important. So for instance, if you wanted to calculate what the flow rate was given by the formula minimum of demand comma capacity. Now, if you did not have information on what your demand is going to be, you will not be able to calculate your flow rate, right? Similarly, when we are doing our calculations for inventory, whether it was or your calculation of reorder point, everywhere, if you look at it, there was your demand that was appearing, right? Even in reorder point, you still said that mu into L, right? So this particular thing is something that we talk about as demand forecasting when we are trying to predict what our demand is going to be. So your understanding of demand is very, very important in any type of analysis that you do in operations, and hence it is necessary for us to find out ways to do forecasting, right? Now, just to take some examples of what kind of things that you would probably see, especially in, for example, in manufacturing, we've seen donor companies, one company where demand variability was very, very high, and if they wanted to expand their operations, would they have a good understanding of future demand because it's completely variable. Similarly, Shorty's Hospital said that they wanted to add an extra floor or make use of the large unutilized space, 1,200 patients, but what is the growth or decline in the number of hernia operations that are required, right? Would the lifestyle of people increase or decrease the total number of hernia operations that are there? Similarly, these kind of demand requirement for such kind of manufacturing or services demand is not only in these particular sector, even in policy setting also, demand distribution, demand understanding is very, very important. This we have seen especially during the what happened during the demonetization, or in 2019, whether it was Narendra Modi or Rahul Gandhi who was getting elected, right? So these kind of demand for the votes was also something that you would have thought of. Now, if you don't have a good understanding of this particular techniques, you either have to be somebody like a magician, somebody who is not what they call as a muggle, need to be a wizard, or somebody like this for you to probably get the right answer. What is your demand going to be? For all mere mortals like us, we have this concept of forecasting. Now, what is forecasting? Forecasting is nothing but it's an estimate of the magnitude and timing. It's very similar to our answers that we sought when we were discussing about inventory management. How much to order and when to order, right? It's very similar to that. Whenever we're talking about demand forecast also, looking at what is the magnitude and when is it going to happen. Now, especially this is for the uncertain events that are going to happen, right? Now, as an estimate tool, this is used in making complex decisions, especially when you're having the uncertain environment. While there are other things that are there in this particular slides, you can go through that. I will quickly jump directly into the tools and techniques that are being discussed, right? So let me skip this particular part. Now, what are some of the tools and techniques that are generally used in forecasting? Now, forecasting, when we're talking about demand forecasting, especially, there are majorly two different types of approaches that we have for forecasting, right? One is what we call as a qualitative approach to forecasting, where what happens is the decision on what the demand is going to be is based upon your soft understanding of what things are. For example, if you are a consultant who is working in this industry for the past 20-25 years, you generally have an idea of what the demand for some new product that is introduced going to be, or what is that demand that is going to be, especially if you are changing your prices and things like that, right? So that's what qualitative approach is going to be. Now, there are different techniques that are generally used in qualitative methods, some of which you have studied as part of your RMD course, things like your survey-based techniques. There's a method called as Delphi method as well, where what happens is a group in this particular field usually come together, and they have what we call as a blind way of trying to identify the exact estimate, right? So it's almost like if you would have seen some movies like 12 Angry Men, it's like a jury, right? Nobody knows what each one's decision is, but they try to write it on a piece of paper, they pass it around, they identify, okay, this is the value, then they kind of correct it based upon the understanding of why this particular thing is wrong, right? So eventually they come to a conclusion that this is how the demand is going to be. That's what a Delphi method is. This is one of the qualitative methods that is generally used in the industry as well. Now, what we will focus in this particular course is primarily going to be quantitative methods, right? And what are those quantitative methods? There are two major types of quantitative approaches to forecasting. One is what we call as a regression-based technique. Learned regression as part of the business statistics course. And so I'm not going to spend time on what is regression-based techniques, but there is also what we call as time series-based models. Now, especially when you are given data on previous past occurrences of what demand is, if you have to predict or forecast what your future demand is going to be, we are primarily going to apply time series models. Now, not that regression-based techniques are not correct. We'll see, and we'll probably even apply that in the case that we are going to discuss. But these kind of models are what gives us an understanding of time series models gives us an understanding of what past data is going to help us in identifying the demand is going to be, right? Now, let's primarily spend some time in trying to understand what these time series models are. Before we go into understanding these time series models, we need to understand the components of a time series model. Now, data, these are some of the terminology that we are going to look at is something that is thrown around very loosely, but there is a technical definition that is used, especially when we are talking about time series models. Now, the first thing is when we see that there is data which is either on average increasing or on average decreasing, that kind of a particular component is called as a trend, right? As long as it is a long-term increase or a long-term decrease, that is what we call as a trend. Now, to give you an example of what a long-term increase is, we know that on average, the population of the earth is increasing, population of India is increasing, population of any particular city or state is also increasing, right? So that's an increasing trend. Now, similarly, if you want to take for the decreasing trend, what could be some of the examples? Some of the examples could be terms of the natural resources. Natural resources, availability of natural resources or renewable resources are usually, non-renewable resources are usually going down, right? So that's a downward trend. Now, apart from trend, there is another component in time series, which we generally see in some kind of data, which is as seasonality, right? Now, a seasonal pattern is something where there is reoccurrence of a particular phenomena again and again at particular intervals of data. Right now, this could be within the year, within the week, or any particular period of time. Now, don't get carried away by the word season over here. Season does not really mean the season as in the general understanding of what a season is, but it is something that has some kind of periodicity that with which it repeats, right? Now, for instance, if we want to say that, let's say you have a class on every Monday, or you have a class every Wednesday, that is what periodicity is. So similarly, and you would see that for many different types of products, you will have the seasonal pattern, right? Like for instance, as mentioned over here, there is a spike in demand for rainy coats, especially during the just before the rainy season, or stationery for school and things like that, right? So several products you can think of, things like ACs, refrigerators, all different kinds of products which have seasonal patterns. Now, apart from this, in general, especially when you're looking at very long-term data, there is something called as cyclical patterns. Now, cyclical patterns are things related to your largely your macroeconomic patterns, right? Now, these are related to business cycles that you would have probably read as part of macroeconomics, that especially any economy usually has to go through kind of crests and troughs. There are regions where there is expansion of economy, there is regions of contraction, especially your recession or depression, things like that. Those are what cyclical patterns are about. But in this particular course, we are primarily going to be focused on these two aspects of the data, right? That is a trend and a seasonal pattern. We'll also understand how do we identify this whenever a data is given to us, right? Now, just to give you an example of how what data is and what kind of pattern that you can see. To start with, if you can see over here, on average, you can see that there is a downward trend over here. And similarly, on average, there is a upward trend over here, right? Similarly, you can see that if you look at the data over here, there are some crests and troughs, but maybe within certain cycles, you can actually see that there is some period crest is actually having, or high that you can see over here. Now, this kind of indicates that there is some kind of seasonality in this particular data, right? Now, this is indicating seasonality, this is indicating a trend. Now, if you look at the fourth graph that we have, this is from the daily change in Dow Jones Index, which is a market index. Now, you can clearly understand that this is purely a random data. This does not have any seasonality, nor does it have a... So on average, if you actually look at it, you can definitely say that this is going to be 0, right? The average of what you can see. So there is no trend or no seasonality over here. Now, how do I kind of put these forecasting models into use, right? Especially these time series forecasting models. Now, there are many different techniques that we can talk about. We, in this particular course, are going to discuss about these 4 major types of forecasting models, among which these 3 are primarily your time series based models, and regression, as we know, is a regression based model. Now, what is naive approach? Now, naive approach is, as the word suggests itself, it is very naive. Now, imagine if I were to ask you that what is the temperature in Trichy going to be tomorrow? Now, and I say that you don't have any other data, but you might have access to data, but you do not have access to sophisticated calculations. Immediately, one's thought process goes back to what was the weather like yesterday, right? Now, if at all I'm going to predict tomorrow's temperature based upon what the temperature was yesterday, that kind of approach is what we call as a naive approach, where if I can draw parallels from that into the demand forecasting, if I'm going to say that my demand tomorrow is going to be the same as what my demand is yesterday. That kind of an approach is called as a naive approach, right? A naive approach is where I'm predicting that tomorrow's demand is going to be yesterday. Right? So the symbol that we use for forecast is given by the letter F. So if I am saying that I have to predict the forecast for the period T, the time period T, by naive approach, I am saying that this is going to be equal to the actual value, or sometimes you also represent it by the letter D, of the previous time period, right? Actual of time period T minus 1, or D or demand of time period T minus 1, right? So Ft is going to be At minus 1 or Dt minus 1. It's not divided, it's either one of them, right? At minus 1, or let me represent it well over here so that you don't have any confusion. It's going to be At minus 1 or Dt minus 1 based upon what is the letter that we generally use. Now, obviously, because of the way it is looking at it, this is not using any other data point other than the last or previous data point. Now, what if you are given data on the last 1 week's data, right? If you don't have access to very sophisticated knowledge of how you are going to do this forecasting techniques, generally one's approach would be to identify, okay, if I have the range of, let's say, 1 week's temperature in Trichy for the last 1 week, I am going to assume that it's going to be very similar to the average of that, right? Now, especially if I am going to go based upon a simple average, this is what is called as a simple moving average. Now, in a simple moving average is generally represented by the two letters MA. Simple moving average is nothing but the average of the letter sigma over here, capital sigma represents the letter sigma represents over here summation of all the previous data points that you have, all the previous data points that you have divided by how many ever numbers that you generally have. A simple moving average. Now, so the forecast for period T plus 1, let me call that as T plus 1 because I have used T over here. The forecast for time period T plus 1 is going to be, let me put it this way, right? Let's say N over here and T over here, so that for time period T, let me just write it correctly over here so that you don't get confused. So Ft plus 1 is going to be nothing but sigma of, let me use another letter, maybe I is equal to 1 to T minus 1, At minus 1 divided by 1 to T minus 1 would be T minus 1. So that would be my simple moving average, right? So if you have data for last 7 items, you take an average of that. This is nothing but, right, average of all the previous ones, like A1 to A2 to till At minus 1. This is what a simple moving average is going to be. Now, sometimes you might have more understanding of what the demand is going to be. Maybe I would want to, if I'm going to, let's say, forecast data on a Wednesday, I would want to give more weightage to Wednesday, last week's Wednesday's data, and maybe some weightage to the others, right? Now, such kind of forecast that you're going to do is what we refer to as a weighted moving average, right? A weighted moving average is where I'm going to not just take a simple average like this, but rather I will say that why don't I just take some weights that is from I is equal to 1 to T minus 1, WIAI, right? Here again it has to be AI, not dt minus 1 divided by sigma of I is equal to 1 to t minus 1 wi. Right, so this is what a weighted moving average is going to be. I am going to give more weight to a particular time period or a particular data point in this whole thing, right? Now A represents, here again I repeat this particular thing, A represents the actual demand or the previous demand, not the forecasted value, right? So forecasted value Ft is going to be weighted moving average, this one. Now the only problem here when you're talking about weighted moving average is, now you are doing this analysis, let's say you have data for about 4 or 5 data points. You will have to choose weights for 4 or 5 different data points, right? Now if you have 100 data points, you will have to choose 100 such weights. Now as a researcher, as a person who wants to identify this forecast, it becomes very difficult for me to identify weight for everything. Now, I could go simply and say that I will give the same weight to everything, that will translate this weighted moving average to simple moving average, but that's not helpful for us, right? That's where people have thought about that instead, apart from identifying previous n data points, not only identifying n weights is very, very cumbersome rather, right? So for that reason, they have come up with a new technique which is called as exponential smoothing. Now, exponential smoothing helps us identify that using just one particular parameter, right? Instead of n weights that we can see over here, what we are going to do is we are going to only use one weight, that is alpha, right? Now, in this particular thing, what we say is that the new forecast, Ft plus 1, or even Ft, if we want to say whichever way, t plus 1 is for the future, right? So that's the reason why I'm using the convention over here. Ft plus 1 is going to be Ft plus alpha. Alpha is the what we call as the smoothing coefficient. This is called as smoothing coefficient multiplied by dt minus Ft, right? So this is the formula that we will use in exponential smoothing to predict what this Ft plus 1 is going to be. Now, let's try to understand this exponential smoothing slightly better, right? What are we saying over here? Ft plus 1 is equal to Ft plus alpha into dt minus Ft. Okay. If I can rearrange this, this becomes what? Ft plus alpha dt minus alpha Ft. So can I say this is nothing but alpha dt plus 1 minus alpha Ft, right? So Ft plus 1 in the exponential smoothing, that is the future forecast, is going to be alpha times the demand in the previous period plus 1 minus alpha times the forecast in that particular period, right? Now, what if alpha is equal to 1? What will happen to this particular equation? Why don't you substitute that? Would see that Ft plus 1 becomes nothing but dt. Now, what kind of a forecast is this? Ft plus 1 is equal to dt. Now, this is nothing but our naive approach, right? So when I substitute alpha is equal to 1, my whole thing is moving towards naive approach, right? So when I substitute alpha is equal to 1, this becomes naive approach. Now, what if I am saying that alpha value is something very, right, not 0, because when I substitute 0 over here, Ft plus 1 is equal to Ft, which I cannot ever identify because I don't know what Ft is, right? Now, let me expand this a bit more, right? What does it say? Ft plus 1 is equal to alpha dt plus 1 minus alpha Ft, right? Now, can I write Ft based upon the previous values also? Like, this is nothing but alpha dt minus 1 plus 1 minus alpha Ft minus 1, right? So this equation becomes 1 minus alpha, alpha into dt minus 1 plus 1 minus alpha Ft minus 1, right? Now, Similarly, I can write ft minus 1 also based upon previous values. So I can keep on continuing that, right? So what this becomes equal to actually ft plus 1, which you can also check in your textbooks as well. This becomes alpha dt plus alpha into 1 minus alpha dt minus 1 plus, again, what will you see over here? Alpha into 1 minus alpha whole square dt minus 2 and so on, right? Now this keeps continuing throughout. Now let's take a value of alpha, let's say it is 0.9, right? What would this equation become? ft plus 1 0.9 dt plus, this is what, 0.9 into 0.1, that becomes what, 0.09 dt minus 1, right? If you don't understand this, please rewind and go so that you will get that part. What I have done over here is just substitute the values of forecast from the previous values just as a recurring formula based upon this, right? And this keeps continuing. Now, if you look at these two weights over here, right? Again, if you go by over here, this will become 0.009, right? dt minus 2 and so on. Now, look at the gap between these two. What is it? This is something about 0.81, right? The difference between this weight and this weight. In fact, this is nothing but very similar to our weighted average. Over here, the gap is between these two is very, very high. Now, if let's say I don't keep alpha is equal to 0.9, I take some value of alpha very close to 0. Let me start with 0.1, right? If that is the case, then what will this happen? ft plus 1 0.1 dt plus 0.1 into 0.9 whole square. That is how much? Sorry, 0.1 into 0.9. So that becomes 0.09 dt minus 1 plus 0.1 into 0.9 whole square. So that becomes 0.081 dt minus 2 and so on, right? Now look at the weights over here. This is 0.1, this is 0.09. So what is the difference over 1, right? Now if this is 0.01, what does it suggest? It suggests that the difference between these two is not very much. Now when will you see the difference between the weights not very much? That is exactly nothing but your simple moving average. Now look at what we have done over here. Just by changing the value of alpha, from the exponential smoothing, I arrived at one which is naive approach, right? One which is like a weighted moving average, one which is very much similar to a simple moving average. So the beauty of exponential smoothing is by changing the value of alpha, you can achieve almost the same type of thing that you can achieve in simple moving average or weighted moving average, just that the value of alpha is only one particular parameter that you have to identify. Unlike what you have to do over here in weighted moving average, you have to identify multiple weights, right? So that is basically the beauty of this. Okay. Now these are what we call as forecasting methods. But how do you make sure that your forecast is actually good or not? You need to identify some metrics, right? If I'm saying that tomorrow the weather is going to be cloudy, or tomorrow if I'm going to say that it is going to be 19 degrees centigrade. Now, what is that that tells me that my forecast is correct or wrong? It all depends upon what we call as the error term, right? Now, like you would have seen in regression as well, there is also an error term over here, which is represented by epsilon or e, whatever you want to call, epsilon t or et, which is nothing but the difference of the forecast from what the demand actually is. Now, obviously, once we move from today to tomorrow, we know what our exact temperature is going to be, right? But today I made a forecast for tomorrow that would be given over here, and this is nothing but tomorrow's temperature. The difference of these both is going to be represented by your error term. Now, ideally, if I want, I would have made multiple forecasts. Let's say if I am going to make a forecast for the next 1 month, I'm going to make at least one about 30 odd forecasts, right? I'm not going to make a decision of how good my forecast is going to be only based upon one metric or one particular forecast. I'm going to take an average of these different forecasts. Now, the only problem with taking a simple average is that today, let's say I predicted that tomorrow's temperature would be 19, and we found out that actual temperature is 31. So the difference is what? Forecast is 19, 19 minus 31 is minus 12, right? Now imagine if I am forecasting day after temperature as, let's say I would predict it as 43, 1, then the error term is going to be plus 12. If I take a simple average, what will happen? Both of them will cancel out and the average is going to be 0. Now, what would my forecast accuracy show on paper if I take a simple average? It will tell me that my accuracy is perfect, 100%. That is, my error is 0. That is completely not right, because whether I do error on the right side or the left side of the exact value, I'm still making an error, right? And hence, what we will do is, instead of taking a value which is absolute, we will take the absolute or the unsigned value of that particular error term, which is represented by this absolute value that you would generally see as part of your Excel or any other thing. This is also referred to as mod. This particular thing only returns the magnitude rather than the sign as well. So this particular error metric that we use, which is also called as forecast accuracy measure, this particular thing is what we refer to as mean absolute deviation. This is what is called as mean absolute deviation, right? So in mean absolute deviation, this is going to be just the absolute value of error term, right? And take an average of that. That is nothing but my mean absolute deviation. Now, I can either take an absolute or I can simply take a square value. Now, when I take the square value, this is called as mean squared error, right? This is called as MSE stands for mean squared error. MAD stands for mean absolute deviation. Now, the problem with these, they are dependent upon what units you use. Let's say, for instance, me and somebody else make this the forecast of temperature, one in Celsius degrees and one in Kelvin, or one in Fahrenheit, let's say, right? Now, if we look at equally different from that, then we will find out that just because I'm using a different measure or different metric or unit, you will find that our MAD and MSE values are going to be different. Now, to solve that particular problem, we came up with another particular metric which is called as mean absolute percentage error. Now, what we are going to do is, here we are going to take a percentage of what the previous demand is actually is. So it's a value corresponding to the demand of it, the error corresponding to the demand of the previous, the period that you are looking for, right? So this gives you the mean absolute percentage error. Now this is agnostic of any units and does not have any units, and hence this is considered in most industries, this is considered as a metric with which your forecast is actually good or not, right? Now this is with respect to our time series based models, right? Now we said that there are regression based models as well. Now regression based models, what you have seen as or studied as part of business statistics was when there are, let's say there is one particular variable X and there is one dependent variable Y, you said that you could study the relationship between this, that this is beta naught plus beta 1 X, which says that over here that there is a linear relationship that exists between this, and beta 1 tells you the slope or the relationship between how as 1 unit of X increases, what happens to the Y, right? Now this is what you had studied. Now the thing with our data is that our data is primarily going to be based upon time, especially demand forecast, right? You will have to forecast demand based upon previous values of demand. Now let's say the previous values of demands are going to be like this: D1, D2, D3, and so on up to some D10, let's say, right? 10 periods of data you are given. Now you will have to forecast what D11 is going to be based upon this. Now how will you use regression to probably tell this particular thing? Now remember what we saw in our the components of time series. We said that there are major things that we want to look at. One is what is called as trend. The other one is seasonality, right? Now, when do we say that there is a trend in the data? Now, we said that the trend in the data is there when it is either increasing or there is decrease, right? So, as long as you can indicate that there is going to be increase or decrease of any particular phenomena with time, if time is on the x-axis, that particular thing is called as trend. Now imagine you are saying that your demand is on y-axis, time is on x-axis. Now when do you say that there is a linear relationship between these two? Can I say that when I can represent D is equal to some A plus BT, then there is a linear relationship between D and T? Now whether it is increasing relationship or decreasing relationship, this particular line equation will definitely represent that there is going to be a trend in the data. The only thing is that when will this particular thing represent a positive or increasing trend? Then when this particular positive, right? So your understanding of what the slope is, the slope here is positive and hence B has to be positive. So whenever there is an increasing trend, this B value has to be positive, and whenever there is decreasing trend, this value has to be negative, right? So this is what trend is. So this is how, if there is trend in your data, you can represent using regression, using the relationship between demand and trend like this. So if you draw a linear relationship between demand and trend, then you can say that there is a increasing or decreasing trend. Now, how do we identify seasonality, right? Now, seasonality identification is a slightly tricky thing, which we will probably discuss in the class tomorrow whenever we are discussing about the case. All right. Now, seasonality, if you are interested, you can go back and check in your the textbook as well. This particular thing we will represent in regression using what we call as dummy variables, right? Now, dummy variables are something similar, nothing but your binary 1-0 kind of variables. But if we have to put seasonality in a regression equation for forecasting, we represent that using dummy variables. What are these? We will understand in the case. All right. Okay. I hope this is this particular data that we have discussed about forecasting should be enough for you to understand and apply some of the principles of forecasting to solve the case on Marriott. All right. Okay. I think this should be any more understanding of it. Please refer to the textbook, and I'm sure you should be able to solve the case as well.